Okay, Algebra 1 review final for Cardinal Newman, 31. Says simplify. Simplify the radical expression. -4 times the square root of 80. -4 times the square root of 16 times 5. -4 times the square root of 16 times the square root of 5. -4 times 4 times the square root of 5 equals -16 times the square root of 5. -16 root 5 is about -35.777. -4 square root 80 is the same. So that will check that at least you have an equivalent expression. It won't check that it's completely factored, but this one looks like it is. 32. Is the square root of 63x15 to the 15th power. y9 over 7xy to the 11th. So let's simplify what's in the square root, because that is just a power itself, right? The square root is to the 1/2 power. So 63 divided by 7 is 9. X to the 15th divided by x to the 1st is x to the 14. And then y to the 9th divided by y to the 11th is y to the -2. So let's rewrite that a little bit. There's a couple ways to do this. 9x 14 over y squared. So I'm writing the negative exponent as a fraction. And then I will separate this into the square root of 9x to the 14 over the square root of y squared. Square root of 9 is 3. Square root of x to the 14th is x to the 7th. And then the square root of y squared is y. They may want us to leave this as an absolute value, or that may not matter. You can also change this to a 1/2 power, and then you're raising a power to a power, and you just say x to the 14th raised to the 1/2 is x to the 7th. Let's see what 33 looks like. 33 says simplify the radical expression by rationalizing the denominator. 5 over the square root of 15. So I can't simplify the square root of 15. I can't factor out a perfect square from 15. It's just 5 times 3. So what I'll do is I'll multiply top and bottom by a form of 1. As long as it's a form of 1, it doesn't change the value of the expression. And I'm going to choose the square root of 15 over the square root of 15. So when I multiply, I get 5 root 15 over the square root of 15 times the square root of 15 is the square root of 225, or 15. And then I'll just make this 1 over 3 square root 15 over 3. And if you want, you can check, say 5 divided by square root of 15 is about 1.29, or I can do the square root of 15 divided by 3. I get the same thing. Again, that'll tell me that these are equivalent expressions. It won't tell me that I have the proper form, but it's a good idea to check just to see. Tell you you're on the right track. Camera may get a little shaky here. Okay. Not perfect. Alright. Solve the equation, check your solution. 2 equals, this is what, 34? This is the, I'm starting with the second half of the review sheet. This is where I left off last class. So this is 2 equals square root of p plus 1. So that's not under the radical. Okay. So I'll subtract 1 from both sides. 1 is equal to square root of p. Square both sides. I get 1 is equal to p, and we'll check that. 2 is equal to the square root of 1 plus 1. 2 is equal to 1 plus 1. Checks out. And we have just one solution. Okay, 35. Square root of the quantity 3x minus 10 is equal to square root of the quantity x plus 10. Okay, so what happens when we square both sides? Okay, I don't want to keep leaving these equal. I will get 3x minus 10 is equal to x plus 10, and then I will say subtract x from both sides, and I'll get 2x minus 10 is equal to 10. Add 10 to both sides. 2x equals 20. Divide by 2. Divide by 2. X equals 10. So I'll check that. This is the square root of 3 times 10 minus 10. I'm checking to see, does that equal the square root of 10 plus 10. I get the square root of 30 minus 10 is equal to the square root of 20. Square root 20 equals square root 20, right? So our solution is over here, 10. What we get when we put it back into the equation is the square root of 20. We're just making sure that those equal each other. So it should be x equals 10, one solution. Here we had x equals 1, one solution. And you probably should write them x colon 10. Okay. Oh, where are we? Find the mean and range. Alright, so we give a list of numbers. This is number 36. 21, 35, 27, 19, 35, 20, 20 again, 21. So I'm going to list these from least to greatest. It looks like 19, and then I've got 20, 20, 21, 21, 27, 35, 35. So how many are in my data set? 1, 2, 3, 4, 5, 6, 7, 8. So if I have 8 numbers in my data set, an even number of elements in the set, and I want to find the find the mean. Sorry, I may have said median before. If I want to find the mean, I don't necessarily have to put them in order, but now that I have 19, 20, 20, 21, 21, 27, 35, 35, total 198, divide that by 8, which is the number of data points in the set, and I have my mean is 24.75. And what else did it want? The range. To find the range, I take the greatest number and I subtract the smallest number. 35 minus 19, range is 16. 37 for 2 weeks. I'm going to read it out loud. Mark recorded the color of traffic light at the intersection of Main Street and North Avenue. At his school bus approached the intersection, results were okay. And then they give a list of red, green, and yellow, and we want a frequency. We probably want a tape. You probably want a title, so you might write out, traffic lights at the corner of Main Street and North Avenue, but you don't need to know where it is to make the frequency table. So I'm going to just do like a rough graph. And then you've got red, yellow, green. And now I want, all right, so let me just count them out. Red, 1, 2, 3, 4, 5, 6. Let me check that. 1, 2, 6. So we'll go 1, 2, 3, 4, 5. There's 5. So I would like, you could, if they don't want a bar graph, they want a frequency table. So you like make 6 X's. That's close. And then yellow is just one yellow. And then your green would be, let's see, I'm looking at a list on the sheet. 1, 2, 3, 3. Red, green, green, green. Okay. So you just make 3 X's. And then it wants the mean, median, and mode of the data set. No, I'm sorry. That goes for 38. It didn't make sense to have an average of something that's qualitative, like red, yellow, green, that you're not, even though you're counting the number of them, the data set is red, 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 red. So I'm not really averaging the colors. I mean, I guess you could, but it wouldn't be a number. So that's our frequency table. So they're giving us another list for 38. And I'm going to go ahead and try and clean this up a little bit. And I'm not going to post the study guide itself, although I'm writing out most of the questions. All right, so 38. So, okay, so what do we got? 10, 8, 9, 10. 10, 8, 9. 11, 1, 15, 12. 13, 15, 15. So let's try and put this in order. Shouldn't be too bad. 1. And then what's next? Looking at that, looking at you, 8. And then 9. Any other 9s? No. 10. 11. 12. Oh, sorry, I already messed up. There's 2 10s. 12. 13. And then the 3, 1, 2, 3 15s. Okay, so how many, well, if we can do the average. 1 plus 8 plus 9 plus 10 plus 10 plus 11 plus 12 plus 13 plus 15, 15, 15, 15, Alright, so 119, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I divide by the number of data sets. Does it say round? Round to the nearest tenth? To the nearest tenth is 10.8. Sure looks like it. Well, the 1's going to throw it off. I'm looking at it going, maybe it's higher, but the 1's definitely going to throw it off. So what else do they want? The median? Well, now that there's 11 data sets, so I will have one number that's in the middle, right? So if I sort of lightly 1, 15, 15, 8, 9, 15, 13, 10, 10, 12, so there it is. So once I list them from least to greatest, if I have an odd number of elements, in this case I have 11 numbers in the set, then the one in the middle will be the median. If I had an even number, like if I only had 10, I would have to average the middle two. I would take the mean of the two in the middle. But since I have an odd number, the median will appear on the list. Mean, median, and mode. So the mode is the mode will always, unless there is no mode, it will appear on the list, because the mode is the number that appears most frequently, and that number is 15. Right? It appears 3 times, but our mode is the number that appears the most often, so that's 15. Okay. Make a box and whisker plot. Okay, box and whisker. 39. A different set of data. We should be able to do it down here. And then how many? Okay, 21, 30, 26, 29.